And then from 1 to n.
Ni divided by mi.
Yeah.
So chi-square of c minus 1 degree of freedom.
Yeah.
So I can use n or c.
Yeah.
Or c.
Yeah.
Ni equals npi.
Because pi it's ni divided by.
Yes. And
And
this
then
is
mi.
n by I.
Yeah.
Now, log of 1 plus x equals x minus x squared over 2 plus x3 over 3 minus for all real numbers x such that absolute of x is less than 1. X minus x squared over 2 plus, and then plus x5 divided by 5, etc.
Okay.
Now, in order to use this, we need to have 1 plus something. So, this is what we're going to do, right? G squared equals 2, sum I equals 1 to c. I'm going to change ni to npi. And write log of ni is npi. This is n pi I. So that the n cancel. Sum I equals 1 to c. I move the n outside, so that gives me 2n. Now, here's the trick to create that one. Pi I minus pi I plus pi. So that this minus this is 0, and you still have your pi I, but this over this will give you 1.
So you just add n minus pi I.
That's it.
Wherever you cancel them, you have this, still have the same.
Yeah.
Okay.
So then g squared equals 2n, sum for I equals 1 to c, pi log of this over this equal 1 plus pi minus pi I over pi.
Also, you just flip it.
Yeah. Now look at the condition. Absolute of x must be less than 1. It means x is between minus 1 and 1. This is the same as saying minus 1 less than x less than 1. So let x equal pi minus pi I over pi I. Log 1 plus this equal x, this, minus this square over 2, and we're going to neglect the other two. It's an asymptotic convergence. So it has
two values.
Exactly. You don't have to take all the terms.
Just a minute.
So this is g squared equals 2n. I equals 1 to c. I. So now I'm writing the formula x. So you have
Pi I.
Minus pi I over pi I minus the same thing, square over 2, right?
Over 2. And then you neglect.
Now here we're going to do another trick. I'm going to change pi in something that involves, I want to write pi as something that has pi minus pi I. Pi plus, well, minus pi I plus pi I. So we do this exactly the same trick. And then here, pi minus pi I over pi I minus half that squared. Okay? So g squared equals 2n. I equals 1 to n. Now because I have pi minus pi I, this in bracket, pi minus pi I plus pi I, and then times it by this. So, okay, if you want, minus half squared. So this time this is pi minus pi I squared over pi I. This is a power 2 term. If you do this time this, it's going to be power 3. So we have to neglect this part.
Okay.
Now if you do this time this, you have a power 1 term. So that's good. So everything up to the power 2. Okay, so this is going to be what?
Pi I.
Pi minus pi I. If you do this time this, you still have a power 2 term. Okay. Minus half.
To the only pi I.
Minus pi I squared over.
No, we cancel.
Cancel one. No, over pi I squared.
No, but there isn't any square here.
Over pi I.
Why?
Because this guy because you still have a power 2 because of that power, but this guy will cancel.
No, but the only x power.
You have pi minus pi I over pi I. So if you square it, everything has to be squared.
Okay.
But this guy, when it multiply this,
Cancel one term.
exactly, it can cancel one
Okay,
term.
can you keep it? Because I need this stuff. This is the trick test. Okay, and then you write it again so that it will be
2n equals 1c. You have pi minus pi I over pi I minus 1 over 2 pi minus pi I squared over pi I plus pi minus pi I plus
again pi minus pi I, and then we add pi I, and then after you multiply them.
Yes.
So
I'm trying to keep the maximum power is 2. So when I pass 2, like when I get 3, I'm gonna neglect the terms. I'm not gonna take them into it. If I do this time this, I get this time this, I'm like, oh, this is power 3. So I don't add that term. This time this, I have this because they cancel, and this time this, I have a power 2. They cancel, so I have this. And if you multiply this by the rest, it's gonna be power 3, so we don't care.
okay, so we take it as a common denominator, and then you say 1 minus half.
Yeah.
Okay.
It's like having a minus half a.
Okay.
Okay?
But
So,
pi it will be outside. Pi minus pi I, this guy.
I feel so
Really?
sorry for you. Believe me, one day you're gonna tell this story to your kids. You're gonna tell them, study hard. Because mom has a story for you. Life was really...
Yeah.
Yes, Alia. Okay. So, no, g squared. G squared equals
2n
2n 1 to c pi minus pi I squared over pi I plus 2n sum I equals 1 to c pi minus pi I plus that. Okay, so maybe I should put a bracket here.
No, I
Why?
didn't get it. Because there is 2 pi I minus pi I. Why?
Okay, so I'm just putting these two together first. What is this minus this? I'm claiming it's equal to half of this. This is these two put together. Do you agree?
Just see, I say that it will take pi I minus pi I divided by this, and then you put bracket 1 minus half.
Yes.
So when I multiply them, it will be the same. This
Yes.
one and this one. Why you put half?
What is 1 minus half?
Half.
That's
So
it.
tell me this.
Okay, I'm telling you this minus this equal half.
Okay,
So what about this?
perfect.
Okay, the sum of I equals 1 to c of pi equal what?
1 minus 1 will be 0.
Thank you. So that gives you this.
So we end with this guy.
So we end up
N
with this.
goes
2
2
go
goes
with
with
2,
2.
n. We do the same trick, n over n squared, go in. We have our chi-squared.
Can you do it?
Okay, so g squared equals n, sum I equals 1 to c pi minus pi I squared over pi I. And what happened to the 2's? 1,
Goes.
2 goes with 2, and
We create n divided by n.
n over n pi I.
It will be
This is n outside here. Pi minus pi I, so that it shows that it's an asymptotic convergence. Now n squared goes in, so you have n pi minus n pi I, the whole thing squared over n pi I. So you put the n outside, n squared, you get this, and p minus this is squared. So we have the same thing. And this is ni, this is mi, this is mi.
But
And this is, yeah,
just a minute. Pi I, it's what again?
n pi I will be mi.
So n squared with n, and then you will be I. It will be
Yes.
ni divided by n. So
Yes.
n goes with n squared. So we end with n by I. be ni squared and divided by n squared as well, because all of it's to the power squared. And this n squared, so
They cancel.
cancel, okay.
Mashallah. G square equal then chi square plus that. So that G square minus x square give you 0 plus that. So then I say, okay, fair enough.
Can I just a minute?
We're done. We have G square equals x square plus that. So that G square converges in probability to x squared. G square minus x squared, you have 0 plus that. So this one converges in probability, and this is an asymptotic convergence area. But
Asymptotic mean goes to 0?
yeah, you want me to clean everything?
Yeah, because I did. No, that's it.
This is square root of n1 plus log minus,
Yeah, 1 minus by I given what?
I 1 given 1.
Ah,
This is our troublemaker. We need to get rid of this, and we'll get. If you want to get this, you have to find the expected value and the variance.
before you did
The expected value of log p1 given 1 minus log.
Yeah, I did this.
Yeah. So what do you get? Remember, this is a constant, right?
Yeah,
So this time this, that is the expected of all these should be equal 0.
yeah.
So what is
The
the expected of this?
It will be 0 because it will this and the log of this, it will be by 1 given 1.
Whoa, I just want the expected of this.
Okay.
So you divide by square root of n1 plus, here is square root of n1 plus, so you get 0. Okay, so the expected of this equals 0.
But what I did, I take the expected of the log by n given 1, and then I take the 1 over by 1 given 1, right?
Yes, yeah.
So when you put it together, so it will be 1,
Yeah.
right? And then how can be 0?
Back to this. I know that the expected of all this equals 0.
Okay.
So if I put expected of this, I have 0.
Okay.
So I move this outside, it's still 0. I divide both sides by this, I get 0.
Okay.
And 1 plus. It's still
That's it.
0. Now, I only want this because I know this is going to be a normal distribution. I just need to find the expected value. And
Well,
it's okay, but I don't see why you
I didn't equal.
Yeah, but you see, your problem is, of course you're going to get this. Because it's like, you tell me all over, I don't know, my name is Alia. I say, yes, your name is Alia. Now tell me more.
Okay.
The extra thing I want to know is, when you don't have this guy, what is the distribution?
I see.
She doesn't have this.
So I have to use this fact, but I equal 0 and equal this fact.
Exactly. So the variance of log p1 given 1 minus log pi 1 given 1. So the variance of all this, we know it's going to be n1 plus, because they squared. It should be equal to.
Wow, I see. This is why she get n.
Exactly. Now she divide by n1 plus, and she got. Here now, what is the variance?
It will be divided by n.
Yeah.
Okay, the same idea when you did the other part, but it will be divided by n2.
Yeah. Exactly. The other one is going to be the same thing, but so n1 plus. What is the distribution of this? Log this minus log this follows a normal distribution
With a 0
like this. So a converging distribution to n 0, but the variance is going to be this. That's where this guy comes. And if you do the same thing for the other one, and you minus them, now we can minus because we don't have n1 plus n2 plus to bother us. So this one goes with the 1 p1 given 2. This one goes with, so it matches like perfect.
For me,
So
let me divide by dividing by n1 plus.
divide by n1 plus. And if you look at here, yeah?
And then with its variance, we add those guys, the variance of those
Exactly. The variance always
Mm,
add up.
okay.
And that makes sense because remember variance of x minus ax plus by,
guys. Yeah, get
a
it out,
squared,
squared.
b squared. So
Yeah.
even if it's minus, it's going to be positive.
What's the true covariance? That's
No, look at this interval. It was 0. What?
0.048,
Okay?
0.00106.
This is a confidence interval. If you were to make sense of this, you would say there is whatever 95% of chance that this interval contains the true, what was the null.
For this one, they said that
Checking to see if P1 given 1 was equal to...
yeah, people who suffering MI when they
Compare-
take the placebo is equal than the people who suffer
If the
MI.
null was true, the difference should be equal to 1.
Why?
If they have the same proportion, if the proportion of the people who took aspirin
The same.
is equal to the proportion of those who are on placebo.
Okay,
But if A equals B, what is A minus B?
0.
Interesting. This is a confidence interval for the difference. So if you do this minus this, you should expect to have 0.
That we accept the hypothesis.
Exactly.
The
When
difference
we minus
between
this,
them
should be 0. That is, this confidence interval, which is the difference, should contain 0.
Should be 0.
It should have 0 in it.
But this is 0. There is a lot of 0 here.
Oh yeah, 0. Look at this interval. 0 is here. This is 0.00.
Yeah, this is what I mean. The whole number should be 0.
Yeah, but 0 is outside. Look at this number 0. It's not even in the range. Here you have 0.004. No. What if this number was here, minus something? It would contain 0.
If it's minus, it will contain 0.
Yeah, because if it was, suppose you had minus 0.7, then your confidence will go from minus 0.7 to 0.0106, but now you have 0 in between.
Contain.
It's the number 0.
I have to add this.